This is a video for AQA Mechanics. This is Impulse and Momentum section 2.4, where we're looking at successive impacts with a smooth plane. Well, to do this I want to just consider an example. And in the example we have a ball of mass m which is released from rest at a height of 12.8 meters above the ground. Of course, what's going to happen is the ball will fall, hit the ground, bounce, and then bounce again. We want to consider after two bounces, what is the height that the ball actually reaches. We're told further that the coefficient of restitution at each impact is equal to 3/4. So let's consider the first part of that motion then, when we start off at a height h and then the ball falls to the ground just before the impact. So we can say, let's consider the speed of the ball before that impact. So let me call that u1. Now we've got total of potential energy at the top as it's starting from rest, and that's converted into kinetic energy at the bottom just before impact. We can say that the potential energy at the top is equal to the kinetic energy just before impact. So therefore mgh is equal to 1/2 mu1 squared. And putting in the values into that, we're asked to take g is equal to 10, so we've got m multiplied by 10 multiplied by 12.8 is equal to 1/2 mu1 squared. We can see that the m's cancel from that. 128 on the left hand side multiplied by 2 gives us that u1 squared is 256, and therefore u1 is the square root of that, and that comes out to be 16 meters per second. So at that first impact then we have an initial velocity there of 16 meters per second. What then happens is that we have a rebound, so there's a collision, and so let's take that rebound velocity there as being v1. Now we can say that the coefficient of restitution E, which we're told is 3/4, and that's the speed of separation. Well, the speed of separation between the ball and the ground is just that velocity v1 that we want, divided by the speed of approach, which is u1, which we'd calculated to be 16. And therefore v1 is equal to 3/4 of 16, 12 meters per second. Now what happens is that the ball rises up to its initial, so it's its first height, h1, so that kinetic energy is converted into potential energy, but then reconverted in kinetic energy just before the second impact. So at the second impact we have u2 must be the same as v1. So at the second impact again we'll get E is 3/4, and that will be then equal to the speed of separation, which I'm going to call now v2, which will be then divided by the speed of approach, which will be equal to 12. And therefore v2 is equal to 3/4 of 12, which is equal to 9 meters per second. So the situation that we have after this second impact then is that the ball is moving with a velocity of 9 meters per second and will rise up to that second height h2. So again we can use energy and say that the kinetic energy at the bottom there, which is 1/2 multiplied by m multiplied by 9 squared, will be equal to the potential energy at H2, so that's M multiplied by G multiplied by H2. The M's again cancel, so we can see that we've got 81 divided by 2, so 40.5, and divide that by 10 G, so H2 must be equal to 40.5 divided by 10, which is 4.05 meters. Well, that's the end of this video looking at successive impacts of the plane, and indeed it's the end of the section of videos on impulse and momentum.